isn't it? But all you have to remember is that it's good. It makes everything work better, right? And these are things we've only discovered in about the last 10 years. So new stuff, right? When I was in college, they told me that you'll never regenerate brain cells, so don't drink too much. Don't fall on your head too often, right? Because you're going to damage it. But guess what? That's not necessarily true. And I'm going to show you how that works here. So the brain is like a muscle. You need to exercise it. All those mechanisms that I talked about, it's exercising the brain. Physical exercise, mental exercise. Those are both critical things. So just to give you the process, in 1995, it's interesting that we haven't spent a lot of time studying this stuff, but one of the most significant studies out there on cognitive decline. It's not the university, it was at the Institute for Brain and Aging and Dementia at UC Irvine, and a guy named Dr. Karl Kottmann. 1995, he set out, in fact, a little before that, set out to find out what do people have in common that stay really alert as they age, that don't have cognitive decline, right? That have, sharp minds. Well, there were three things that they found that these people had in common. They looked at almost 700 participants in this particular study. And the first one was, and again, whenever you do a study, right, you have these hypotheses, this is what I think is going to happen. And one of the hypotheses said that education is probably going to be part of it. And they were right. Everybody in the study that really didn't have cognitive decline, they were not only well educated, and it didn't mean they had a whole lot of degrees, it's they just liked learning all the time. So maybe they learned how to tie flies, and maybe they did Sudoku. They were very engaged in learning. They liked learning. Again, doesn't mean degrees, it just means that you're always stimulating your mind, wanting to learn new things, and that can be a lot of different stuff, right? Second one was self-efficacy, that they had purpose in their lives. Probably heard that someplace before. They had a sense of purpose in their lives and accomplishment, and that means, family, and that it could be your faith, it could be a lot of things, but that you had purpose, that you worked. Do you ever meet somebody that retired for real and see them kind of decline very quickly? But then people that have retired but not really retired and they're always engaged, they still really engaged. That's very important as human beings to have. The third, and that wasn't a surprise, by the way, that people had self-efficacy. The third component, which was a complete surprise to them, was that they all were active people. They were all exercised. They were all active in some way or another, meaning that they always walked or they rode their bicycle and they've been doing it for years and they gardened. Some were more directed exercise, but they were very physically active people for a lifetime. And that was like, wow, that was weird for them. They didn't really put two and two together thinking that would impact people's health, right? Because we separate everything out. Right? We get smarter just by reading a book. In fact, right now in schools, they're saying kids should sit down in the classroom more time, and that's how they're going to get smarter. They're going to learn more. And it's actually not true. Studies show that it doesn't work. In fact, I'll quote one of those studies in a second. So Kottmann and his researchers wanted to understand why this happened. So to make a long story short, they discovered in mice that ran on treadmills a lot had tons of BDNF in their brains when they dissected them, and they had more long-term potentiation, meaning they had really strong, fat, plump brains with lots of BDNF, healthy, strong brains. And they thought, that might be it right there. So his take-home message right there was, and this was, what was it now, 20 years ago, or not quite 20 years ago, 15 years ago, and he said, take-home message is exercise leads to improved learning. How fast we learn, how well we learn. That was his comment. Makes sense, right? So going down the path, 1998, Fred Gage, Peter Erickson, Henrietta Prag, the Salk Institute. This is a think tank kind of research institute, and they do a lot of research on a lot of different things. That's all you need to remember. Again, you don't have to remember all these things. Just these are smarties, right? And they discovered that in the center of your brain, there's a thing called the hippocampus. Looks like a little horseshoe. That every day the hippocampus produces blank slate stem cells. And you guys have heard of stem cells, right? Stem cells are going to do this, that. They're basically blank, meaning they could be almost any cell. And, talk around science is that we could take a blank slate stem cell and turn it into a lung cell. We could turn it into a muscle cell. We could turn it into a lot of different things. The body does that. It actually takes these blank slate stem cells, and they're released. And if this blank slate stem cell is released and stimulated within a 28-day period of its release, it will be drawn into the brain, and it'll turn into a new brain cell, a neuron. And that's how you regenerate brain cells and create new brain cells. So, I talked about engaging your mind. Well, what they also found out is that the mice, the decay was slower, meaning that at 28 days they stayed robust, those blank slate stem cells. Plus the brain produced many more of those blank slate stem cells in physically active mice. Right? So super active mice had more opportunity to create more brain cells. And they were healthier, more robust potential brain cells. So what do you want to do if you want to build some brain cells? Well, maybe go out for a jog and then do your Sudoku puzzle, or go practice your guitar, or maybe go exercise before you have to prepare for a meeting so you can remember all that information. It's a great way to develop those big, powerful, robust, neural integrity-filled brains. So, pretty interesting, don't you think? Fast forward to 2006. They had seen this in mice in 98, and this other PhD, Scott Small, he's, actually MD, neurologist at Columbia University, used a new MRI. And they're cool MRIs. They actually let things, that you can actually watch things happen in real time while they're going on. And guess what? He saw this exact process that I just described happen in human beings real time. Amazing, right? In fact, right now they're trying to discover the neural pathway. They want to duplicate it. Imagine exercise in a pill. They're trying to do it. In regards to how it affects your brain, it's never going to be duplicated. Remember I talked about the synergy. You can't duplicate it in a pill. It's impossible. But imagine if you could have that pill. We'd sell a lot of that pill, right? But guess what? We have the answer right now. They want to create this pill to help people think better. Do we have the answer? Right? I think this tells me, go out for a jog, for a walk. That will trigger these mechanisms, and it'll do it 1,000,000 times better than a pill will ever do it. All right? So, let's talk about what affects that neural integrity. So now we know that we can actually grow brain cells. And this is real. This is something that happens every day in all of our bodies. Chronic stress, depression, those are things that actually damage brain cells. All right? Excess production, and this is just one of the mechanisms that can cause this, is cortisol. Cortisol is actually a hormone that helps with energy transport. And you're going to notice those insulin, those growth factors that I talked about, those are actually energy transport systems too. Diabetes, disease in diabetes, that's an energy transport system. Interesting how all these energy systems inside your body, how our fuel works, is really associated with a lot of health, right? Anyway, cortisol is actually not a bad hormone. It's good. You need it. It helps you actually transport energy to the brain and other organs when you're stressed, fight or flight, right? You got to take off, or you got to put up and fight something off. What happens, though, is if we're chronically stressed and feeling bad, overproduction of this will help store more fat, which is energy. It stores it right here. Right? Plus, that cortisol damages that neural integrity. In large amounts over time, those little connections that we want to keep, they get damaged, and then we get that pulling apart, and we get the drop in neural integrity. Right? So, kind of interesting. And I think I'm doing a good job. I hope that our body's a lot of chemistry. A lot of things go on inside our bodies and help us feel better. It's how it triggers everything. How muscles contract, everything. And there are 3 major neurotransmitters that your body produces: and serotonin, norepinephrine, and dopamine. You've probably heard those terms, right? Certainly on TV commercials that are selling you antidepressants. They always talk about how it affects these chemicals, right? And these are 3 what we call balancing hormones. They actually can or neurotransmitters. They actually can mimic other hormones and other neurotransmitters, and they help us feel good. They mellow us out. They actually bring balance to our lives.